So maybe if each of you could introduce yourselves and say a little bit about your background and just a little bit about your company before we get started. Yeah. Maybe Hans, you want to go first?
Yeah. I'm Hans Lene here, VP Marketing at Trent Miner. Before joining Trent Miner, I came from an analyst perspective in the data center infrastructure world. But today I'm very excited to be here in the process industry and analytics on top of that.
Good morning. My name's Mike Brooks. I'm president and CEO of MTEL. I come to this with many years in operational and maintenance experience with large oil companies, Exxon, Chevron. I've done 5 startup companies. This is my 5th one. And all to do with industrial IT, those kinds of things. The company itself started in the business. We basically weren't an analytical company building a platform for, as I say, special mice and then going looking for special mice. We came out of the business to stop machines breaking, and we assembled the technologies, to get that done with all the context and all those things that are required.
Test. Is this on? Yes.
Yeah.
Hi, I'm Brian Parsons. I'm one of 2 founders of Seek, and I serve as the CTO. My background originally was in optimal control theory, but I've spent my entire career doing asset management, abnormal situation management at everything from a transmitter, a DP cell, up to an entire refinery. A big stint of that was at Honeywell, but I've been in this space doing analytics on equipment and processes for basically 34 years.
Thanks, Brian. Okay. So maybe I'll kick things off. Yusuf, one of the things that you talked about was culture change, and that's really consistent with a lot of the themes that we've heard at the conference around disruptive change and changing the way we do things, being able to predict maintenance events before they happen, or predicting where the process is headed. If you're in a refinery, you want to predict if your column is flooding, or if your exchangers are fouling, or if a compressor blade happens to break off a very expensive rotating piece of equipment. So how do you see, and maybe each of the panelists, you can tell me what your view is on this, how do you see the role of the engineer and the operator changing in the future with the new tools that are available to you? Yeah. Yusuf, you want to start on that one?
So as we went through the pilot and we realized some of these changes with the operators, we gave them the tools that they needed before the locomotive arrived, so they were able to be prepared to maintain and to troubleshoot that locomotive. So it's really changed the way that we do business from a maintenance standpoint, because we can plan ahead material, personnel, and capacity at our locomotive shops to really drive efficiencies.
So I think ultimately you were asking how the role is changing, is that right?
Yes, yeah.
So I think the engineer in general is tasked with looking at more types of data, certainly more volume of data. There are fewer engineers available, and they are becoming more distributed. So the role of their need to collaborate with each other and deal with remote access is certainly growing. And on top of all that, I think the role of the engineer is now being recognized as essential to understanding the business. So the number of asks and their being more into the critical path of business decisions, I think, is also growing at the same time. So more data, fewer people, and bigger problems at the same time.
Okay. Mike, you want to take that one?
Yeah, I kind of can reiterate some of the things that Brian just said. I come to this and I look at everything that's been said about predictive analytics and IoT, and one thing I've read is that we're going to need another 100,000 data scientists by the year 2020. And I ask myself, well, where are they? They're not in school right now. And if you're going to use that to get the problem solved, the problem's not going to get solved. So we took a hard look at this. We've been doing this for 8 years. And, one of the things that we decided is that people should not have to know more than they already know to be able to solve the problem. And that the problem should be positioned in such a way with the solution so that the rocket science is built into the product so that you don't need to be a rocket scientist to use it. That means that the operators and engineers, the guys who are closest to the machines, are in the best position to make the appropriate decisions when the software can do the data collection, do the analysis, and do this within minutes. And not only do that, but prescribe the appropriate action. It was a gentleman at BP who said to me, hey, I can use these analytical tools. I can find a needle in a haystack. But you know, at the end of it, you've got to answer the so what question. What am I going to do about it? So being able to provide that prescriptive action to allow you to understand what's going to happen, when it's going to happen, why it's going to happen, and what you can do about it is very important to those people who are closest to those machines.
Well, I should copy whatever has said before, but because you're actually entirely right. We do not have the data scientists, and furthermore than that, technology should cover for that problem. One of the things I could add here is that there's a lot of workforce that will be leaving the industry very soon. We're getting out of the baby boomers are almost up for retirement, and they're not being replaced. And one of the things we have noticed with process engineers and everyone around is that there's a lot of the knowledge is in the assumption and the experience and the bias of the user himself, but is not captured and not shared. So even on your picture from your trains, in the trains itself, we're using paper logs. In the facilities, the operators are still using paper logs for their shifts. And so that knowledge from the operator is not shown in the data for the process engineer. And I think that is going to change as well, and the tooling is going to be there to help you.
Any questions from the audience? Preet in the green sweater has a microphone. If you'd just like to raise your hand, state your name and your company, and we'd be happy to table a question.
Yeah, Mike Desert from ArcelorMittal Dofasco. So we've been in the predictive analytics business for over 20 years there, so we have been doing things that have been really interesting, and it's great to see a lot of new tools and technologies going out there with a lot more data availability there. I guess I have two questions. One of the things we really struggle with is data pre-processing, how these tools handle all that, and the complexity of things like missing data, noisy data, data that really is bizarre and then it becomes good again there. That's real industrial data. We deal with that all the time. The other one is, what are the technology engines that you see in terms of these analytics? So there's all kinds of different technologies, multivariate statistics, Bayesian networks, decision trees, all these kind of unique statistical and advanced type of tools there. Which tools do you guys see as kind of the future going forward there, or the ones that you see will be really valuable just from a technology suite?
Well, we got a CTO on board.
Yeah, so a couple of big questions there. First of all, data quality is kind of paramount. It's hard to do analytics when, garbage in, garbage out. So I think your question is kind of geared toward specific answers for how our solution might work versus others. I'd rather answer the issue generically on behalf of the industry, which is that you have to have some management of that data such that you can identify and fix flyers, gaps, deadlines, outliers, et cetera. And if that's not an integrated part of the solution, it's pretty much a non-starter. What's interesting is that when you look at use cases in the field, the amount of time that people spend preparing the data to do analysis is around 95%. Okay, so when you say, when an engineer gets a phone call that says, boy, I want this report, he starts sweating because to do the report is an hour of work, and he's got 2 weeks of work to do to prepare the data to get to that point. So obviously that's a major focus for us. I'm sure it is for the others up here as well, and I just want to recognize that it's a major part of the problem that people should not overlook. The second piece is that, again, you're asking about specific things. Our approach is that there is no winning technology. It's going to take all of these to solve these problems. So Seek's position is that we want to be an integrating, I don't want to say the word platform necessarily, but an integrating means so that the tool of choice that's appropriate for a particular problem can be applied. Our focus is on enabling the engineer to use the appropriate tool in an integrated fashion. So we believe that the engineer plays a super critical role. There's understanding in his head that is not in the data. And without the ability to apply that to whatever tool is being appropriate, it's just, numbers. if you have something smart looking at things and say, hey, look at me, I think there's something wrong, you still need a guy who understands the process or the plant or the equipment to apply that expertise. So our focus is not on the algorithm, our focus is on the process and on the human usability for that information.
So I'll answer with the exact same thing. When you asked for specific technologies, the answer is going to be all of the above, right? But the problem we've had with previous analytics, and I'm not trying to offend anyone in the audience that does this, is we've started with a whole bunch of data that is available. We said we want to do analytics on top of that, so we look at which are the analytic tools that are available to go into that data as such, and then see which tools can we build on top of that to make it a view, make it dashboards, KPI monitoring, however you want to do that. However, it's done in other big data solutions. Now, what we've done, and actually I've seen Seek does the exact same thing, is we went to the process engineer, and we asked the process engineer, what is the tool you're using in your daily work? And then we're going to look back, which are the technologies we can bring into your tooling. So the process engineer is using a trending client. So we should bring the analytics into that trending client, because that's where and to your first question, how do you eliminate the noise? Well, you eliminate the noise by eliminating the maintenance periods, because they are irrelevant if you're looking to an event that happened within your process as such. You are eliminating all the other products that were running. If you're looking at a temperature tag, you don't see which product was running at that point in time. So you start by eliminating all these things to start off with. If you give your data 5 million points of a single data set to a data scientist, he's going to give you a lot of nice things, but he's going to give you 95% false positives, right? The only person who can actually say this is relevant data or not is the process engineer himself.
Any other comments? Mike?
Yeah, so I can add to this. I can reiterate, Brian said about the data quality. I mean, it's one thing that we looked at, and I looked at our CTO, and I said, when I initially looked at the product, I said, it doesn't scale. It doesn't scale because, as much as he said, 90% of the work up front is in doing the data quality assessments and to understand what data that you've got and the data that are good. So we put a lot of work into automating that process. You never get away with it completely. There are also some parts that you need to do. We've used machine learning algorithms. We continue to use state-of-the-art in those, in all its different forms. And machine learning tends to be tolerant of noise. It doesn't get rid of all of it. But we take the viewpoint that the end user shouldn't need to know which algorithms. And frankly, I usually in my presentations, I show a slide, the iceberg, and I tell you, algorithms are only 10% of the solution. It's what you wrap around it in terms of to do that data analysis, to do that correlation, to understand what happens when you've got missing data and the time series don't align appropriately. It's about those. It's about the alerting engine that goes around them. It's about the other data sources besides the historian. That is not the only place where you're going to find data that correlates with the events that are happening in your process. The maintenance system, for example, an event tracking system, your IntelliTrack, your mobile system where you're collecting data randomly. All these become part of the source and become part of that solution. And it's how you deal with that. We basically don't ask the users to select the algorithms. We do what we call now ensemble learning. We might try many different algorithms in the background and pick the one for you that best suits the solution. If you want to be the data scientist, you want to be the rocket scientist, we will give you open access to Apache Spark and all those algorithms, and you pick the one that you think makes the most sense. But we've tried to make this so that Joe Normal can do the work with what he knows now.
Thanks, Mike. Yeah. One of the risks, and if I could use the early example of a black box, and in the process industries, they have something called multi-variable control or advanced process control. So the early implementations of APC were plagued with being complex modeling, heavy training required to support, and very, very difficult advisory systems. How are systems different today from the older systems that were black box and complex?
Maybe I'll take this one first. One of the things we've learned at Trent Miner is that the process industry is not one vertical. The process industry is a whole series of verticals that go from all the way from trains and oil and gas, minerals and mining, up to the electronics. And there's a big difference in focus on when you're running a 24/7 plant with 700, 5,000 trains. It is different from a process that has a whole line in your plant. And there's not a single, even if you have 5 plants that are identically designed, they are different, the process that is running. The managers and the CEOs will tell you all our plants are perfectly designed the same thing with the same materials. The process engineer and the operators will tell you that every single one is different. So in order to find something, in order to be able to find a specific event, in order to troubleshoot a specific event, you cannot rely on pre-built models that are running for 5,000 exactly the same things if you are not in that area. So if you are, for example, we have polymer plants. We've got paper and pulp customers. I got a paper and pulp customer with 150,000 tags in one single plant. Not a single one of them is the same. So you're gonna need other tools than black boxes with a model that is prescribed up front that you're just running for 5 years. You're gonna need more agile models that can help solve your question when you wanna ask the question and not 5 weeks later.
Okay.
So I like to add some to that. I think if you look at the early approaches in this, and it covers a number of approaches that are out there that purport to do the same predictive analytics. Lots of companies will tell you that they can do it. That's CSX. In the end, they looked at a lot of companies, and in the end, they said MTEL is the one that can do it, for their particular application. So, when you look at this and you look at what's going on here, some of the early approaches, as my colleague here said, uses modeling techniques. Now, when I talk to people, I said, that's not what we're doing. We're learning the models from the data, from the equipment. Why is that different? Well, because it's dirty. It's not pristine. It's not hygienically clean, and it doesn't fit. And I tell people, when we're looking for precise patterns that show degradation. These are precise patterns measured from the machine, not made up by humans, not made up by models that only work over a close range, after which you have to wrap a rules engine because it wants to tell you there's a problem that's not really a problem, so you want to throw that message away. That doesn't make the model any better. When you measure it from the machine, then you can determine very precise patterns. You can do profiling from the ground up. When you see a bearing failure, and we've proved this to people out there who are the subject matter experts, who will tell you that this is the cause. And you can look at those profiles, and I can tell you, these 5 are the same. They have the same profile all the way through. This one was a bearing failure, was caused by something else. We've had that discussion many, many times. So you can do that. And you can do that with precise pattern recognition. In addition to that, you also have to do what most of the people are trying to do here is called anomaly detection. And anomaly detection and precise pattern recognition are very, very different. Precise pattern recognition is much more accurate, gives you the warnings much more early with more precision. Anomaly detection, which is what most guys who are trying to do this are doing, only asks one question. Is this normal? That's all it asks. You've all been aware of this. This is what the credit card company does. When they say, sir, did you really spend $1,000 on a bottle of champagne? They've learned your spending behavior, and now they want to classify an anomaly. Is this you, or is this fraud? We're doing exactly the same with the machines. We find a pattern, we say, is this normal? Oh, yes, we put the pump in recycle mode. Check. That gets added to normal baseline. You will never get a false positive from that again. It is a learning system. That's what's happening with machine learning. That's not what's happening with a lot of the earlier statistical techniques that sometimes are called the best of yesterday's technology.
So a couple observations I can add to that. You talked about the black box strategy for what was around for 15, 20 years. And what the black box failed at was understanding that everything in the plant is changing. The materials are changing, the recipes are changing, the equipment's changing, the equipment's fouling, things are getting recalibrated, the people are changing, and it's continuously happening. So when you have a black box that's looking at one data source, it does not have that context to apply. On top of that, there are multiple things a black box may want to look for. And the easiest way of saying this is that one person's noise is the other guy's signal. One guy might want to say, see all this high frequency stuff that's getting in the way, take it out. And the other guy says, hey, that increase in high frequency stuff is exactly what I'm looking for. A black box doesn't understand this. So the key to all these solutions, and Seek in particular, is to make it easy for the context to be applied to the data, and that's what's new versus black boxes. The context might be what's in people's heads, it might be coming from other systems, but somewhere there's more information than just what's in the data coming out of an historian, and that has to be applied in an intelligent manner. And that's, we're all saying the same thing.
Okay. Now, Yusuf, from an implementation point of view, your opinion on black box and supportability is really important here. If you have any comments of having gone through a specialized system, that would be helpful.
So as you can imagine, we had a bunch of black boxes thrown at us throughout this whole process. And they all promise the same thing. It'll work in your application because it's worked in the airline industry, it's worked in the trucking industry. But they left out that although they're all transportation industries, the railroad's completely different. We even had one black box tell us we've worked in your competitor's industry, Norfolk Southern. Said, well, their railroad's a little bit different than ours. So when we were searching for a solution and came across MTEL, the fact that it had all the variables kind of wide open was impressive. Our director of finance was able to create a rule in less than a minute. And our data scientist was able to go in there and change algorithms. So how it was packaged was impressive, and that's kind of what drew us to it.
Okay, thanks, Jeff. Now we have a question over here.
Sure. Yeah, this is John Campbell from AspenTech, and AspenTech, of course, does a lot of modeling, so we value that a lot. And I think that because it's first principles, chemical engineering-based model, we can provide something maybe that feeds to these solutions that could then be used to find problems. I think when we talk about not wanting the users to be data scientists and experts, they don't care what the algorithms are, they care about the results. But they need to, and I think Brian addressed this, they need to talk about the context of the problem they want to solve. So how do we get context? In the case of having 22 measurements, there's not a lot of context that's maybe needed that worked pretty well. In the process industries, you might have thousands of tags, and you're looking at things. And if you can get the user to provide the context, Hans, you talked a little bit about operator logs. What is the strategy for making this usable and getting the context out of the process engineer's head and into the problem-solving process?
Yeah. So it's exactly what we did. So actually, Aspen is one of the one of the three historians we tie into. So very happy to have you in the room. What we've done is we just created a very simple system that does annotations on top of your tags as such. It is a time-based annotation. The annotation could be made manually by an operator and saying reactor 5 when in maintenance mode. You push one log, and that specific point in time is put on all the tags that were relevant to reactor 5 at the same time. So if you will be doing a search in about 3 to 5 months to an anomaly that happened, and we do a historical search, we get some results. The results that have that tag, whether or not it's on a temperature, pressure, or level tag, whatever tag it is going to show you this was maintenance mode, so it's exclude that from the equation. Now, on the other hand, if you, for example, have found a pattern that is an anomaly, right, we can save that anomaly, and when new data comes in, the system will recognize that pattern as in, this is something you've already recognized as being an anomaly. We can automatically add a tag in it again. So you don't even have to do it manually. You will even be able to have the machine add context to the system itself.
So let me add a little bit. We started off on this journey making machines smart so they can tell you they're going to break well before they do. The way we packaged what we've done turns out to be quite useful for doing process degradation. We've done it in, for example, in pharmaceuticals, in batch work, semiconductor manufacture. And these are places, and what we discover is that the closer that you get to the process and the more process knowledge that you have, you can actually get much, much better at prescribing the actions. So the full solution doesn't just become our black box by itself, but the inputs that come from the users, the events that happen, those declarations that are made, those models turned out to be quite useful. The alarm conditions that are generated by the DCS, the safe operating envelopes that are declared by the process engineer, all those become a consummate part of the solution. And as I said, once you get into more than just machines breaking, how is the process changing? That knowledge becomes more invaluable to combine. So it really is the IoT, that combination of sensors, sensor networks, smart machines, and people that get the problem solved.
So I'll add a little more to that as well. Your question was about how do you address this problem of this context? So first of all, systemically, I think one of the key issues is that when context is finally understood, that it can be added to the system to be repeated automatically. What happens today or historically is someone does an analysis and they might export data to Excel and they figure out what the context is. They may even drag in data from other sources and they annotate it or figure out sections of interest in that environment. And at the end of that study, it's sitting in an Excel file on his desk, and it's wasted. So the system has to be able to capture that context in a way that is both then either federated or established in some way that it can be reused and repurposed and applied to the next problem. That's number one. That's just systemic. In regard to Seek, what we do specifically then is we have a structure called a capsule, which is designed to identify time periods of interest. And that kind of structure has been around for a while. What's different is this is foundational for our system. Just to give you a placeholder for it, we create 1 million capsules a second, where we can go that fast. And the point is not the horsepower. The point is that it's having a means to capture context is profoundly important. Has to be continuous, has to be automated, has to be integrated, has to be part of the entire process. And if it's off of that mainstream, it's lost forever. And if the guy who's got it in his head, if he goes home, it's gone. So it has to be part of the system.
So let me just add one thing to help here. I'll give you an example. We've done a lot of work with compressors. So when you look at compressors and you want to understand what's going on, one of the things that you're going to do is look at all the vibration sensors. Now, that's fine to do that, and it's important to do that. I think one thing to understand in all of this is there's never one univariate sensor that declares that there's degradation happening. And it's never vibration, because vibration is a signature of damage. The damage has already happened. It had a root cause that started that. So you have to be able to look at that. Around that, I want to see the sensors from the process, the pressures, temperatures, and flows on that machine. Further than that, and understand we're talking about machines breaking. You'll hear a lot of talk about MTBFs and all that. Most of that is useless. I said it, most of that is useless. Why? Because most machines do not fail because of normal wear and tear. They fail because of process abuse. That's pumps running dry, that's pumps cavitating, that's liquid carryover, that's dirty feedstocks. These are not measured by MTBFs. So when you start doing your modeling and you look at the sensors that are important, it's often very important to look at what's happening upstream to get that context of what might occur to impact that machine and cause that degradation. And if you can find it that way, you want to do things like Youssef talked about. I want to find the breakthrough of the water in the lube oil. I want to find it early so that I can fix it by changing a filter, by changing the oil, instead of waiting until I've got bearing damage. So it's about that context, being able to understand those early conditions, those root cause conditions that are causing, for example, the vibrations.
Another question over here, sir?
My name is Ademola Idowu. I'm with the Dow Chemical Company. My question is on, we've been talking about black box to specialized solution. And I just want to ask you, from your experience, what are the top barriers that you see in this process analytics? Is it more in the software region? Is it in the hardware? Or is it more about the culture or the people? Because if we understand the main area of barriers, maybe we can tailor our discussion more on what we should all be focusing on, so that we can, we know a lot of challenges that we have, but what are the key barriers?
So I'll take a shot at that one. First of all, there's lots of technology out there, and most of it's been around for quite a long time. Some of it's new. I think the biggest barrier is understanding the work process. And the key factor in the work process is that there's multiple skill sets that need to be applied to a problem. I'll give you an example. You can have a process engineer who understands the process. There's maybe equipment, there's materials, there's the asset vendor, there's IT, there's R&D, there's algorithms, all of which have to come together. Now, if you split those functions into multiple people, with every division, you're making the problem exponentially harder. Imagine you have a car that you bring into a service station, and you have 3 people working on it. One is the car manufacturer, 10,000 miles away. Another is the mechanic who knows how to use the tools but doesn't know what to do with them. Just says, someone can tell him to turn this crank and I'll do it. And a third guy who knows how to talk to the computer in the car. And these guys don't work together well, and they're all in different time zones and everything else. How long is it going to take for your car to get fixed? Right? I think you probably beat my own mechanic, but that's a bad mechanic. So the point is that in a process plant, if you have solutions which take an IT person to go get the data, and you have an R&D person who knows the algorithms, and you have a separate third person who understands the process, another one who understands the equipment, that is creating a challenge. And some of the drivers today are kind of moving in that direction because there's an interest in the technology and there's not a comprehensive solution. But we believe the vision and the problem that people, we hope, see is that you want to put all that horsepower in the hands of the one guy who understands it. And make it so the horsepower is not the issue. It's like, I'm looking at the problem, here's got this tool, this tool, this tool, figure it out right now on the fly. If I need help, I'm talking to my peer, the engineer that I work with. I'm not talking to the R&D and the algorithm and the data scientists and other people. Now, that may be a dream. I think there's certainly good examples of where it's happening today, and we hope it to grow. But that is a challenge, which is this is not a problem to be solved necessarily by IT, R&D, and everything else. This is an engineering problem, and we should bring everything to bear on helping that person get his job done.
So I think, to add to what Brian said, we take a very similar viewpoint. When you're looking at assets and you're looking at asset degradation, one of the things that you want to do is, first thing you understand is, I have an asset. No one department owns it. Operations has to operate it safely. Maintenance has to maintain it. Planning has to schedule it. And technical has to optimize it. So no one department owns it. And you really, at the essence of all this, you're trying to wring the best life cycle performance that you can get out of the asset. The name of this game is better production through what it is that we're doing. That's why you're doing it. So at the end of all that, when a system like ours comes up, like we did for the rail car that gave them 120 days notice that the engine was going to fail, now they've got 120 days to decide what to do when all those 4 departments can talk about what's the best thing to do for the best asset life cycle. In some cases, Yosef told you, it's to run it to failure. It's not always to run it to failure. It might be to do minor maintenance now to make it last until it gets, it might be to move production. But those are the discussions that you're now able to have. When we are looking at a top drive on a drilling rig and it's off the coast of Africa, and they get 30 days notice that the drive's going to fail. They have 30 days to fly a new one out there. That's very different to it failing, and now it's going to take me 30 days to get one there while I've got a drilling rig costing me $2 million a day doing nothing.
I'll take a shot to the second part of your question when you were asking about what is our strategy into technologies as such. Some of the technologies, we've had a habit, and that's throughout all verticals and all industries, to try to buy a full stack from a good provider. I think we are now in an era, that new technologies emerge so fast that it is very hard to rely on one single vendor to provide you the full solution. That's why we partner with the historian vendors, for example. The historian database as such has been around for decades, right? The historian database, it's technically was designed to be a write optimized, to capture all this data every single second. There's thousands of data points coming in, and I have to store these very efficiently. The problem is, why are we not doing data analytics on that historian, is because it's not made to ask those questions. If you look at the slide we had from the use case, MTEL has put all that data from historian into a Hadoop NHP SAP HANA infrastructure. The only reason you had to do that is because that historian was not able to query your question. So we'll have to look for more solutions than one in our maybe quick wins, maybe smaller solutions. But so to your strategy in technology, I think we should look at partnering more tools than buying from full stack vendors.
So I'm going to ask a question now. Many of the attendees that are at this event come from pulp and paper, pharmaceutical, life sciences, oil and gas upstream, petrochemical, discrete industries. And Yusuf, your case of detecting a failure of a process breakthrough into a mechanical system and giving 120 days advance notice is perfect. So where else do you see these types of solutions being used? In other words, what other problems do you think we can solve with this technology?
Well, ultimately, these technologies are all looking at finding information hiding in the data, and typically you're looking at a change in behavior of some sort. So the natural fit for that would be anything to do with reliability, performance monitoring, optimization. But it can also have a good fit for understanding variability and obviously relationships between things, so causality. So they're pretty general. I think the biggest wins initially, especially when you look at the pervasive sensing and additional sensing that's going on, those sensors are being driven from a monitoring perspective. They're not being added for control. And the monitoring is typically around reliability is kind of the key win. So I think we'll see the biggest advances there first, but it can be applicable to pretty much every department.
And so, when we came into this, we basically looking at asset-intensive businesses. I started off this, I've done a lot of work in oil and gas. I like oil and gas because they get expensive kit and it blows up, and they'll pay a lot of money to make sure it doesn't. But given that, you go to pharmaceuticals, their kit's not as expensive, but it's much, much smaller, and the products they're making are very expensive. So those are the places that you start with, but certainly the technologies that we're doing, it's not an emergency shutdown system that we've developed. It's any place where you can detect, and it's an advantage to detect early degradation. Where you can change behavior, you can change process. So we started off with machines, but we've been able to do clean-in-place processes for pharmaceutical manufacture. We've been to look at chillers, looking at glycol breakthrough for another pharmaceutical manufacturer. We're looking at degradation as they grow wafers that take 60 days to grow. And there's degradation that happens over those 60 days. And after 10 days, you can figure out it's broken, but you may not know until the end. So at least we can return it and perhaps fix it, or use the 50 days to make good wafers. I mean, as Brian said, the technology is very, very general. I think that often the context is useful. It's not always absolutely essential. So it can be useful, but as a result, this can be used in lots of places. We've asked people have asked to do all kinds of things, but you know, we're a small company. You have to be focused, and that's what we've done. So we're not doing network intrusion and things like that. Could it be done with this kind of data? Our company's looking at this. Last time I looked, there's like 125 new companies using machine learning to solve one problem or another. You know, so yes, it's extremely useful. You know, this is the stuff that drives the Google car. You know, this is the stuff that does fingerprint recognition. It's the stuff that does voice recognition on your smartphone. This is the technology, and the extensions in the technology, especially by Jeffrey Hinton at the University of Toronto, with deep learning, allows this to behave much, much more like the human brain does, with its cognitive learning patterns and its ability to adjust to changes in behavior and changes in processes. That's what makes it so valuable. What makes it hard, as you said, is that it can be computationally very, very intensive to do the learning. Not to do the pattern recognition, to do the learning. So you have to balance those things.
I'll take it to a generic level over all types of technologies. One of the things you see is the more generic a solution will be, the more industries it will cover, the more time it will take to implement it in your plans, to make it your solution. There's probably a couple of analytics tools that are so generic that they could solve all the problems we're doing. But by the time you have implemented in your plant into what you want it to do, it's going to take you a lot of time. So the younger companies that come around, we're looking at the process engineer in the process industry in a couple of very specific verticals. Like, what's the problem you want to solve? We're going to solve that, and from there on, we may see other solutions. If you're coming into the market with a solution that says, we'll solve all your problems, I'll tell you it's going to be a half-year implementation period.
So also, I'll switch gears a little bit. One of the departments at CSX that's actually using the predictive analytics for something different is our finance department. They're actually using it to get competitive pricing on assets. So whenever we go buy a locomotive and it costs between $2 and $4 million, we don't know what that life cycle throughout the whole life of the locomotive is going to cost us. So they're using the predictive analytics and the repair information that MTEL's giving us to say, hey, we don't think that this pricing is competitive because this asset's going to cost me X amount of dollars over its 30-year life to maintain.
Okay. Is there another question back there?
So this is a question that's slightly off the technical line of thinking. Question is, what is the most comparable business model to analytics tools? Is it like the MATLAB and Simulink? Or is it like the Google search appliance?
I would say that's a hard question to answer. I mean, you know, we can make these comparisons. We can look at, you know, what Google's done. But these problems and the way that they're getting solved in ways that 5 years ago, what we're doing now was unsolvable. You couldn't solve it with the technologies that were around 5 years ago. Google search was around 5 years ago. What Google's doing with the Google car, we're all benefiting, you know, from that experience. Somebody asked earlier about the algorithm. Google makes them free. They publish them. Go have at it. You can get the algorithms. You can get your math and data scientists to go and chew on those. But as we've all said earlier, it's not about the algorithms. It's about what you wrap around it and contextually what you bring to your environment to understand your data and the problem that you're trying to solve. You know, I've heard all this stuff here about IoT and all. It reminds me of 10 years ago when we were talking business intelligence and data warehouse. And I'm famous for saying, that's an answer. What's the question? If you don't know the questions you're asking, you've no business playing around with this technology. Understand the problem that you're trying to solve.
So when I entered this market, I come from the data center background, right? And the first thing I noticed was this is things I've been doing for 5 to 10 years in other markets. So it was very weird to understand why this was not happening already today to that extent. One of the things you can see is that, let's take, for example, in retail. Amazon, if you buy a book, a split second later, it's already going to tell you these are the books someone else has bought for you. That is millions of records, billions of records. It's checking for you while you're doing it. Why is that so easy for them to do? Because it's a repetitive question. It's a single question they have been able to make. They only need the power, the processing power behind it to crunch that number for you. But it is a single repetitive question. The process industry doesn't work like that. In the process, every process is different, and every line is differently assembled. So the question you are asking from a process engineer in one single plant is just not so easy to be repeated over 1 billion assets in the world.
So your question was about business model, and I've got a good answer for you. So today, people imagine that the value of these technologies, and they're correct, could be in the millions of dollars. One catastrophic event avoided is, just enormously, one life saved. But before the traditional way in this industry of installing new software was, a 6-month study, large investments, million-dollar investments, projects that take 2 years to implement, and it was kind of the waterfall approach. Today's experience is you have applications on your iPhone that you download, and if you don't like it within 10 seconds, you delete it and you get another one, right? It happens all the time. You don't read the manual. And we believe that is going to be an influence in this industry as well. Now, if I can talk about Seek for a moment, we have customers. There were 2 studies yesterday here. Iberdrola showed one, and Emerson showed another, where they took Seek almost on a trial basis and solved really large problems that saved hundreds of thousands of dollars. And we have a subscription price, which is 1,000x less expensive than the value they're creating. So you can actually download our software and try it for free, see if it solves your problem long before you've actually paid anything, and applying it and proving it to yourself kind of immediately within a few days. So that's a new business model that is completely new to the industry, and we think it'll be very successful. Whether it is or not, I think those types of business models will start to infiltrate this business as well as every other. As people, the consumers are driving that expectation.
So one of the core elements of the industrial Internet of Things, I have to talk a little bit about this, is this concept of servitization. And we had a great example, Yusuf, of applying this technology to assets that you own. So this is probably a little more forward-thinking, but if you could look into the future in terms of original equipment manufacturers, not just selling products, but selling products and services, do you see the technology that you're using enabling people that make things that spin, or fractionation columns, or exchangers, or chillers? Do you see any opportunity there?
Well, yes. We've already sold to those people who make things spin and who are offering services based on this type of technology. So it's not just us pushing software out to end users. There are those OEM manufacturers and others who are actually embedding this technology to use in their products and offer services to the market. So it's already happening.
I'm going to make it very short. 3/4 of my discussions this week on this floor were OEMs that were asking, oh, can we use this as well? So we're providing this for the customers, but the OEMs are definitely asking for the same kind of solutions.
So yes, here as well. Emerson yesterday showed a great example of how they're using Seek to help their customers manage their assets with remote expertise. But I'll make another observation, which is that the OEM model, even though it, from a business perspective, appears very different from, let's say, an end user using it on-prem, okay, never leaving, there are enormous similarities right under the hood. You have distributed expertise, even within a plant. You have multiple data sources. You have same kind of sensors, same kind of tools. So even though the business for an OEM is different, the system that we're all doing is the same, whether it's an OEM or kind of an on-site use or even a cloud use. It doesn't matter. Same situation.
Okay. Yeah. Yusuf?
So as our team meets with suppliers and potential partners, a lot of the times they'll present their product and they'll tell us we've optimized this product using all of the techniques that these gentlemen have been speaking about. Take our wayside system, for example, that we showed up on the screen. All those algorithms have been developed using signatures that they get as the locomotive and train passes by the rail. So yeah, so this is definitely being used by the OEMs and continues to be a huge part.
Any, one last question from the audience? Is there any closing statements or observations or recommendations that the panelists would have for the audience?
I'll just say thank you. It's great to see so many people here interested in these types of technology that represent a real breakthrough in terms of how we've been behaving in the past and some of the problems that we can solve for the future. And I'm here with potential competitors. I look at this and I see this as a rising tide, and a rising tide lifts all boats. So I'm very happy to be here. Thank you very much.
With the more we are here, the more validation of our message and the more validation that we are actually doing a good job. One of the things I want to actually add to, in general, to the forum as such, we've seen the keynotes, and in the keynotes there was a lot of focus on innovation, on disruption, and I think we'll need more smaller companies that can act faster in the future, and hopefully on the show floor next year we'll see a couple more polos and sneakers instead of jackets and ties.
I would add that the technology can be very sexy, and I think the number of people in this room is a testament to just how impressive some of the technology is. But as much as people like technology, they buy solutions. Technology doesn't solve the problem. You need to look at the whole picture. And one measurement of are you solving problems is looking at the speed with which things can get solved. I mentioned in my very first question that engineers are being asked to do more and faster. The game changer will be when they can answer a question for the business fast enough so it matters to the business. If they asked a question and they come back with the answer 3 months later, it's too late, and that's where things are. So yesterday, Iberdrola gave a presentation where they had a question being asked that was taking them a week to solve. And using Seek software, they're now doing it in 15 minutes on a routine basis. That's a game changer, not because it saved them 3.5 days or whatever it is, but because it's fast enough to matter. And technology doesn't do that on its own. You really have to look at the whole problem. Some of the questions were about that. You have to look at the entire solution and make sure you're really addressing everything. It's not just technology.
Okay, thank you all for attending. It was a great session, and thank the panelists. Thank you.